Hello everyone, I am Dr. Velamani P.S., Professor, Department of Computer Science, University of Science and Technology, Meghalaya. Today we are going to see the theoretical network model, that is OSI reference model and IEEE standard model. We'll see these two models one by one. The OSI model, that is Open System Interconnection Reference Model. So this is the model which is going to be utilized for the data transmission in between sender and receiver. There are 7 layers will be considered under OSI model. We'll see that one by one. So the OSI reference model, in this diagram we can see that this code we need to keep it in our mind: A, P, S, T and DP. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. So this is the OSA reference model, which consists of different protocols, set of rules and regulations which will be utilized for the data transfer. So this entire picture will explain very simply about the OSA model. Application layer, that is the topmost layer level, and it is talking about user interface and services, email or file transfer services. So the connection in the application, it is going to deal with that. Then presentation layer, it takes place the process of translation, encryption, compression. The translation is nothing but the information which is coming from the application layer that will be encoded as a encoded message which can be easily understandable by the system. That is system understandable format message. Encryption talks about the secure level of the information. We have to provide the security standards of the message, security standards for the message. Then the third one is compression. The file or email will be compressed, the size will be reduced, the file size will be reduced at this presentation layer level. Now the session layer, the two process will be takes place: dialog control and synchronization. In the dialog control, session creation will be created. This session creation, full duplex or half duplex. Either it may be unidirectional or it may be bidirectional, that will be decided at this moment. Synchronization, that is a checkpoint creation. So this is a process of giving checkpoints after transferring certain lengthy file. Create a checkpoint, then the remaining information or the remaining file will be sent as a next level. So that is the concept in the synchronization. Then the sequence number and port number. Here we can see from the transport layer, SPFB, segments, packets, frames, bits. So the segments, then packets, then frames, then bits. In the segments, in the transport layer, the data will be comes in the form of segments. Each and every segment will have the sequence number and which port it needs to send that port number also. For example, 80 means that will be indicated here. Then the process to process delivery. Then the stage by stage the information will be carried out from the sender and receiver. That also will be explained at this moment. The third one is network layer level. So this network layer IP address, the correct device information will be given in the IP address. Routers will be used to route to the correct IP address. Data link layer, the MAC address, the medium access control address will be provided to connect with the network interface card which is embedded with the motherboard. Finally, the physical layer which carries zeros and ones through the communication channel to the receiver. So this is the simple overview reference model and which is having 7 layers. We will explain one by one first. Then finally, I will explain how a particular message will be transferred from application layer to physical layer from in sender level to the receiver level. A particular message or particular page will be transferred. I'll explain it. For example, 100 pages will be sent from this application layer. It cross till up to physical layer. How this 100 pages will be received in the receiver layer, receiver side, that I'll explain very clearly after giving explanation on each and every layer. So let's take place the first layer, that is physical layer. It determines the physical characteristics of interface and medium. It represents bits, zeros and ones. So the amount of data transmitted in a given period of time, that is data rate. The line configuration which denotes the type of connection like point to point connection, etc. So two things we need to consider: the bits 0 and 1, then the data rate, the amount of data transmission at a time, then the line configuration, the connection type point to point or multi directions which need to consider, and it determines generally the physical topology of connection between sender and receiver devices. That is our physical layer. So the OSI stands for Open System Interconnection. Second one is data link layer. Data link layer framing, F framing, point to point connection between two devices that consist of a wire in the data transmission can take place as a stream of bits. So physical addressing, MAC address, medium access control, the error control, flow control, access control, these three controls will be takes place. Error control, we need to retransmit the data in case of errors. Flow control, constant data rate will be considered to transmit the data in between sender and receiver. Access control is the control which ensures the message is reaching the correct device or not. So that is the data link layer activity. That one is network layer. So logical addressing. IP addressing, this layer adds a header to the packet which includes the logical address of sender and receiver. Just we need to keep it in our mind IP addressing. So the IP address of the device will be considered to find out the right device to transfer the data. Routing, it ensures the process of path selection in any network routes to the correct IP address. The routing is the process which take place to give the right IP address direction. So that also a concept we need to consider in the network layer. Transport layer, segmentation and reassembly. Here, a message is divided into segments and each segment having sequence numbers to reassemble again. So the segmentation is there in this particular layer level. Service point addressing, it ensures the port address along with the header for process to process delivery. Then connection control, it determines connection oriented or connectionless oriented services. Then as usual, flow control and error control also will be handled at this moment. Session layer, dialog control system communicates in full duplex or half duplex, that is unidirectional or bidirectional, that can be decided here. And synchronization, it allows the process of adding checkpoints. I'll explain very clearly about the checkpoints if we are taking around 500 pages of file transfer. Presentation layer, translation, that is the thing, encoding into the common format of the message. Encryption, decryption, that is ensuring the security of the data it travels between sender and receiver by using some protocols. Compression, decompression, reducing the size of data, which is known as compression. And the decompression restores the original document in its original size. So finally, the top layer, that is application layer, it directs the communication with the user through the user interface. It takes care of file transfer, access, and management. It provides mail services in between sender and receiver. So that's all about the YSI reference model. Now let us see how a 500 pages file will be transferred from sender and receiver at a quick glance. Now a 500 pages file is going to transfer from the application layer, how it takes place. So now 500 pages, it is coming to the 500 this application layer, the user interface. We can see the file will be transferred. We will give the command, and the 500 pages will come to the presentation layer. The 500 pages will be translated as a machine understandable message, and the encryption, the protection, the data security for that 500 pages also will be given over there by using the encryption format. Then the compression, in case of 500 pages, if it is having some 30 MB like that, it will be reduced as 20 MB, for example. I'm saying. Then now 20 MB file, it is coming to the session layer. Then dialog control will decide whether this data, this 20 MB file, 20 MB 500 pages file will go by single direction or it will take care by bi-direction, that will be taken care. Now the synchronization we need to carefully understand at this moment. Suppose this 500 pages comes at this moment, 100 pages will be transferred at each and every time. So after 100 pages transmission, one checkpoint will be given. After then 101 to 200 pages, one checkpoint will be given. Then 201 to 300, another checkpoint. Then 301 to 400, another checkpoint. 401 to 500, another checkpoint. Why this checkpoint is given? In case of In case if checksum method will identify any error in 450th page, there is no need of retransmission from 1 to 500 page like that. So instead of that, we can go to the checkpoint 401, and from 401 to 500 only we can transfer the pages. Thus that particular 100 pages only we can transfer. So that is the use of checkpoint. So no need of retransmission of the entire file. Only wherever the error occurs, wherever the receiver is not received, at that particular 50 page or 100 pages only, based upon the checkpoint, that particular page number of pages will be transmitted. Then the file will come to the transport layer. The file will be divided into different segments with this sequence number and which port it needs to be delivered, and that process to process delivery point will be handled. Then network layer level, the which device it needs to reach, and that particular IP address also will be considered to the data packets of that particular file, and the routing also can be done to reach the proper IP address. Then once the data packets is ready to travel means, then it needs to check with the MAC address, medium access control, which medium it needs to access, and this particular file will be transferred through the LAN cables and it will reach the network interface card which is embedded in the motherboard. And in the physical layer level, this zeros and ones will be transferred in the binary form. The file binary form will be transferred to the receiver level. So the receiver level also the same process will be repeated, and only in the presentation layer level decompression and decompression and translation, these process will be taken place, and finally in the application layer level the receiver will receive the proper information. So this is the process of entire file of 500 pages which will be transferred by using these 7 layers. So now let us move to the IEEE standard. IEEE standard, that is Institute of Electrical and Electronics Engineers, they decided initially a standard the model which is called Project 802. Project 802, which will be used for the data transmission methods. So let us see this particular 8 IEEE 802.1. It deals with the internetworking, especially bridging. It manages and bridges LAN and MAN networks. So we'll see that here 802.1. Then again 802.2, it defines the logical link layer as the upper portion of the data link layer of the OSI model. So we can see to it and upper portion of the logical link layer model. So it is a software component that provides a uniform interface to the user of the data link service. So that is also another thing which we need to consider here. So IEEE 802.3 CSMA bar CD, that is carrier sense multiple access collision detection, which is a medium access control method used mostly in Ethernet technology of LAN. It uses carrier sensing to defer transmission until no other stations are transmitting. So this is the method. So once collision detection, which is the process of listening to a medium to detect if any other station is sending data. If it sends data, it then the data to be sent is backed off and sent at the later time. So by using a simple flow diagram, we can understand this very easily in our next slide. Yes. So CSMA bar CD. Here we can see the sender is ready to send the data. So first it sends the channel. If the channel is busy, wait according to the backup strategy. If channel is free, the data will be transmitted. Once the data is completed, no collision detected, then receiver will receive the data. In case during the data transmission completion stage, if collision is detected, transmit jam signal and it will be moved to the wait according to the backup strategy stage, and it needs to sense the data until and unless if the channel is free, the data will be transmitted, then the transmission will complete, then finally without any collision the data will be received by the receiver. This is the carrier sense multiple access and collision detection process. So now we are in see 802.1, 802.2, 3, 4, 5. So the 5, before 5, the token bus, token ring and all will be there under consideration in the bus topological methods. So IEEE 802.4 token bus. The token bus here, the everything is formed in the form of token. The N1, the sender N1 wants to send information or any message to the receiver, how it can be taken place in the bus topology. So the token passing in LAN is a popular method. Here the physical media is a bus and logical link will be created by using the coaxial cable. To transfer the data from sender to receiver, sender must get the token first from the receiver. So sender will get the token. Then after that, the token will be passed from one client to another client in a sequence of either clockwise or anti-clockwise. So it depends upon the nearest. Like that, it can be done. The data transmission will take place between sender and receiver on the priority of sequence number in token based upon queue. It is just like similar to banking system, cash counter. Somebody is going to withdraw the money and they will get the token, and according to the token number they will wait and they can go to the cash counter and get the money. Like that, this process can be done. So token bus, see you can see here a preamble, then start delimiter, then source address, destination address, the data, the checksum, and delimiter, everything will be there in this particular moment. So the actual data will consist of all these things. The start delimiter, the first start delimiter and delimiter, where exactly it starts, where exactly it ends. In between that, source address, destination address, then the checksum. This is for error detection. Then the preamble, this preamble is for a particular message. Then the next message, then another preamble will be considered. So the advantages The data traffic will be reduced at this moment uh, because the data is traveling from one node to another node with exact source address and exact destination address with proper error detection method with proper preamble start delimiter. With that, the data can be traveled very easily and the traffic will be reduced. The collision also will be avoided. The data collision also will be avoided because the data movement is very perfect without disturbing other data or other information. Then IEEE 802.5 ring, token ring. See the form of ring you can find in this token ring method like ring topology. Token ring. The token will be sent from N1 to N2. The single line will be handled. The single token will be used in between N1 and N2 and N2 and N3, N3 and N4, N3 and N4 and N1. So like that, this can be takes place. The token ring will be divided into different parts and we'll see to it one by one. So the first, the token ring is used in local area network connected to form a ring topology. So ring topology formation that can be handled by this method. So in token ring, only the host will hold a token. So only one token will be held by the N1. It prevents the data transmission from the collision. If one token is handled by the host, then there is no chance of repetition or any kind of collision over there. The type of rings, physical ring, dual ring, bus ring, star ring. The formation will be in different aspects. The physical ring, dual ring, bus ring, star ring. Let us see the connectivity one by one. Physical ring. So the connection format you can find the dot lines, the ring you can see. A, B, C, D, four nodes, one direction it is connected. Physical ring, the path is very perfect. The data transmission also perfect. If one node fails, then the network will be down as usual. Then dual ring, then the same network, but the secondary ring that is again one more extra line will be there. What does it indicate means in case A wants to transfer data to B, if the primary ring is getting failed, the secondary ring will be used temporarily and the transmission can be done properly. So the explanation on this, there are two rings, primary and secondary ring. Primary ring is used for data transfer. Secondary ring is used in case of primary ring failure until it is recovered. As I told already about this dual ring. Bus ring, so this is the bus topological format, you can find it out. And again the line which indicates again the ring, the shape of ring will be there. That is the bus topology, bus ring. So bus is a ring structure. The structure is ring with small entry with the data. It can move from with this format at this mode here from here to here, here to here, and here to here, here, and again here. So this can form a ring between A, B, C, D. That is the format. Again, star ring. So see, the star topology is similar to the format the star topology is there. Within this star topology, the ring format we can find out here. The or star ring, the connection. Again, in between this node, bidirectional connections will be there. So in such cases, data want to travel from A to B either by this way or maybe it reaches here or it reaches here. So it may reach the receiver B at any path at this moment. At this situation, even any node is getting failed, again it will form another ring and there will be no disturbance in the data transfer. So that is the case of star ring. So in case of this explanation, if any one of the nodes getting failed, the remaining will act as the ring. So with this, we can finish this presentation. And so, moreover, we have seen many topics in this video. The summary of this presentation, the number one is OSI model, open system interconnection model, which we have seen. Then in continuation to this, then we have seen IEEE standard, that is project 802, which we have seen, and various type of token rings, those methodologies also we have seen in this particular video. Thank you very much.